Hello and welcome. In this short video, I will demonstrate how you can debug Java using TSI's zTPFGI. So, what do you need to be able to debug a Java program in zTPFGI? Well, you actually don't need anything other than a project that contains your Java source file and a makefile. You can create your Java and source files like you would any other file. In the Host Files view, simply right-click on the directory under which you want to create the file and select New File. Name the file and click OK. And we can do the same thing to create the makefile. Once you have your files, you're ready to write your code. I've already created a project called Demo Java Debugging. So if I now go to the Projects view, you'll see the project that I've created. So now, if I refresh the project, you'll see the new files that I've just created appear in the project. You'll notice that I have in this project a Java program called student.java and its corresponding makefile. I'm going to use these for the rest of this demo. If we take a look at this Java source file called student, we can see that it's like any other Java file. It has the package declared, and it has a public class. It has subclasses and submethods, and it has a main method. There are a couple of things you need to ensure in your Java source file to be able to build it. Firstly, you need to make sure that the package name is the same as the name of the Linux directory and the project name. As you can see here, my package, Demo Java Debugging, matches the name of my Linux directory and the project in the Projects view. The other thing that you need is for the public class to have the same name as the segment. In this case, the segment is student.java, so I have named the class student. Now let's take a look at the makefile. In a makefile for assembly, you'll define an app and an app_entry. But for Java, you'll need to define a jar and a jar_entry. For the jar value, put the name of the jar file. This does not have to be the same as a segment name. Here, you can see that I've put stud so that when I build, a file called stud.jar will be created and put into the load directory. For the jar entry value, put the project name .segment name. So I have here demo java debugging .student. The other thing that you'll need to define in the makefile is the segments to be assembled and compiled. For assembly, you'll define ASM SRC. For CPP, you define CPP SRC. Similarly, for Java, you will need to define Java SRC. This needs to be the segment name and the extension, and as you can see here, I have defined Java SRC as student.java. Now let's build the Java program. You can build a jar file by right-clicking on a segment that is open in the editor, or from the host files view, or from the projects view, then clicking the build button in the pop-up menu. Or you can click the build button that's in the home tab of the ribbon menu, as I'm doing now. It will take just a little time to build the jar file. As it builds, output on the progress of the build is shown in the output window. And you can see now that the build has completed with return code 0, and that the jar file has been created and placed in the project's load directory. Notice that the jar file is called stud.jar. This is because we gave the value stud as the jar definition in the makefile. Now let's load the jar file to the TPF system. As with building, you can do this from the home tab on the ribbon menu, or you can right-click on the segment, or you can right-click on the jar file itself and select Load from the pop-up menu. When the Load Set Creation dialog appears, you can select whether to load selectively or system-wide, and whether or not to automatically activate the load set once it's been loaded to the system. If you want to lock for source view, you can select the appropriate radio buttons. I have selected None, which will not lock the segment for source view. I can now click OK and start the load. We can see from the output that the load set has been successfully loaded to the system. Now that the load has completed and the load set has been added to the load sets view, we can see the stud.jar file. And if we expand it, we can see the student.java segment. We can lock the segment into source view either by right-clicking on it and selecting Trace in Source View, or we can simply double-click on the segment itself. If there's a mismatch between the date time of the loaded segment and the VI file, you'll get a warning message pop up. For the purposes of this demo, we can just ignore this warning and carry on anyway. We can see that the segment is locked because a lock symbol appears alongside the segment in the Load Sets view and in the Source Files tab in the editor. If you have more than one Java project in the Projects view, before debugging, you will need to make the project that you're currently working on the current debug project. You can do this by right-clicking on the project. Then from the pop-up menu, select Java and set as current debug project. You can see that the response in the Output tab shows that the Java debug project is set. Now we're ready to start debugging. To run the program, go to the Projects view, right-click on the jar file, and in the pop-up menu, select Java, Linux, and Run Jar. The program execution stops at the top of the student.java source file. The execution point is shown by a blue arrow and the line of code is highlighted. If you look at the ribbon menu, you'll see that the Debug tab is now showing, and you can see to the left the controls for opening various debugging views: the Variables view, the Watches view, the Call Stack view, and the Breakpoints view. You can also see that the current active resource is Jav1, and we have an active thread, indicating that we're currently debugging Java code. You can also see in the Debug ribbon the buttons Run, Run to Cursor, Step Into, Step Through, and Step Out. Let's look at each of the step buttons in turn. First, let's take a look at what the Run to Cursor button does. Let me put the cursor on a different line to the execution line. Now, if I click Run to Cursor, you can see that the program execution continues and stops on the line where I placed my cursor. Next, let's take a look at Step Into. This button will allow you to step line by line through the Java code. When you get to a line that's calling a method, clicking Step Into will step into that method. You can see that this line is calling myinfo.information. Now when I click the Step Into button, I'm taken into the myinfo.information method. Now that I'm inside this method, I can step through it to debug it, or I can click the Step Out button to run until I return from the method to the line after the line that was called this method, thus stepping out of the method. Next, I want to mention the Step Through button. This button allows you to step line by line through the code. If the line being executed is calling a method, Step Through does not step into the method, but steps through it, so that the method executes, but we do not go into it. If we look at the Variables view, we will see that it's been updated to show the variables and their values. Lastly, let's click the Run button. Run will run the program until either the program exits or until a breakpoint is hit. In this case, as there's no breakpoint set, the program has just run to completion. I hope you have found this video on how to debug Java in zTPFGI informative, and thank you for watching.